Obviously, this whole reaction is done in water, and an aqueous condition में reaction है, which is easily hydrolyzed. So in the presence of water, it will get hydrolyzed and forms HCl. Which can be used back as a reagent. It can be used back as a reagent. Therefore, very little amount of HCl is required in this reaction. Okay, very little amount of HCl is required. Whatever HCl is required, it is getting reformed by hydrolysis of FeCl2. Please write this down. After this, you will write ammonolysis of alkyl halide. Ammonolysis of alkyl halides. This reaction we have already seen in the chapter of haloalkane and halorine. If you have NH3 ammonia and you use any haloalkane like this, now this NH3 is going to attack on the R. Okay, NH3 is going to attack on the R, and you will get this X is going to leave. This is a nucleophilic substitution reaction, SN reaction. Okay, nucleophile is NH3, it attacks here, and you get R that is attached to nitrogen. Nitrogen has 3 hydrogen already, so this will get a positive charge. In order to neutralize this positive charge, you will have the X negative here. Now, further reaction with NaOH in basic medium, if you react this with NaOH, you get RNH2. You get RNH2. Now, you have got, what is this? This is 1 degree amine. But let's suppose you have found 1 degree amine, and obviously you will not, if I take 1 mole of NH3 and 1 mole of alkyl halide, not at a time all the moles of ammonia is going to get converted to 1 degree amine. There will be some that is left, some ammonia will also be there, some alkyl halide will also be there. So when you have RNH2, there are some ammonia left and there are some alkyl halide left. So this RNH2 can again react with what? It can again react with the alkyl halide, and it is going to give you, after NaOH, it is going to give you 2 alkyl groups on the nitrogen atom. 2 alkyl groups and 1 hydrogen. It still has a lone pair electron, so it can still react with, if it finds any alkyl halide, it will still react with alkyl halide, leading to the formation of 3 degree amine. You have Rx, and you will get R nitrogen, again R, and 1 more R. Okay, now it still has lone pair electron, and it will still react with Rx, forming a quaternary ammonium salt, in which you have alkyl group attached with nitrogen, and there are 4 alkyl groups. It will get a positive charge. It will be balanced by X negative. Now this is known as quaternary, because it is 4 degree. Quaternary ammonium salt. Okay, so you can go from 1 degree to 2 degree to 3 degree to the quaternary ammonium salt, and that is why this method of preparation is not preferred. Why? Because if I take ammonia and alkyl halide, then the alkyl halide is the 1 degree amine that is being formed will react with alkyl halide once again to form 2 degree. Then again it will form 3 degree, and again it will form 4 degree. So I'll write a note here. This is not a preferred method of preparation of amines. This is not a preferred method of preparation for amines. ये quaternary इसके लिए यहाँ तक है for amines as it gives. Just a second, guys. Just a second, guys. Okay. Yeah. Right here, this is not a preferred method of preparation for amine, as it gives. Please write, as it gives mixture of 1 degree, 2 degree, 3 degree, and quaternary ammonium salt. Now, one thing that we can do in order to get 1 degree amine as a major product, what we can have ammonia in excess, right? We can have ammonia in excess. If ammonia will be in excess, this RNH2 will not find alkyl halide to react with. It will only find what? Ammonia. Okay. So what we can do? Please write. But again, as a major product, we will still get a mixture, but 1 degree amine will be major product. To get 1 degree amine as major product, what we can do? NH3 should be in excess. Right, next. Order of reactivity of haloalkane. So if I have alkyl bromide, alkyl chloride, or alkyl iodide, which is going to react fastest? So since this is the SN reaction, the easiest to break bond will be fastest. And we know that the longest bond is with iodine. So it will be fastest to break and it will be most reactive, followed by RBr and followed by RCl. RF is so small that it does not even react properly. Write this down and then write a reduction of nitriles. Third is reduction of nitriles. Now, in reduction of nitriles, you can use 3 different reagents. First is the most famous reducing agent, lithium aluminium hydride. Second is again the same thing, H2 over nickel or platinum, mostly, but we use nickel. Okay, so आप यहाँ पे nickel ही रखिए. Third is sodium amalgam. Na in the presence of Hg in the presence of ethanol. Okay, you can use any of these three reagents. And if you have R, C triple bond N, you react this with H2 in the presence of nickel, you will get R. This carbon atom will get 2 hydrogens, and this nitrogen will also get 2 hydrogens, CH2 NH2. This can also be used to get aniline. Not aniline, but I think it is going to be something different because we have a carbon atom here. No? C triple bond N in the presence of LiAlH4. Get CH2 NH2. So this nitrile reaction and the other reaction that is with a Grignard reagent. There is one reaction with Grignard reagent. No, not with Grignard reagent. Okay. Yes, lithium aluminum hydride is a very strong reducing agent. So these reactions can be used, for example, if you have to go from ethanol to propane nitride. Okay, ethanol to propane nitride. So if you have ethanol, that means you have 2 carbon atoms and OH, and you have to go 1, 2, 3 carbon atoms and then NH2. So 2 carbon atoms to 3 carbon atoms. So there is very important thing that you have to do is to add CN. We can very easily add CN on alkyne halide. First of all, you do SOCl2 thionyl chloride, you will get 2 carbon atoms and CN. Then you react this with KCl, you will get 3 carbon atoms, but the third carbon atom is nitride. And it is very easy to go from nitride to NH2, just you can use LiAlH4. You have gone from nitrile to amine. Okay, so this is also having 1, 2, 3 carbon atoms. This is also having 1, 2, 3 carbon atoms. Please write this down. Okay, Fahad. I will look into it. At the fourth one, this is reduction of amides. Now, what is the structure of amide? RC double bond O, NH2. You will add here the lithium aluminium hydride in the first step. In the second step, hydrolysis, and you will get R CH2 NH2. Okay, you will get R CH2 NH2. But the next reaction, which is important, that can come directly, which is Gabriel thialamide synthesis, right? The fifth part. Gabriel thialamide synthesis. In Gabriel thialamide synthesis, we use the phthalimide. What is phthalimide? We have seen the carboxylic acid chapter. Phthalimide is when you have two rings, carbonyl carbon, carbonyl carbon, and NH. Now this hydrogen is very acidic because if I remove this nitrogen will get a negative charge, which can be in resonance with this oxygen, this oxygen. Further, it can be in resonance with this particular carboxyl benzene group. Okay, so this hydrogen is quite acidic, and if you react this with KOH, then hydrogen will be replaced by potassium, and you will get nitrogen K positive. Nitrogen पे आप negative acid लिखिए. This is double bond O. This is double bond O as it is. Negative and K positive. ठीक है. अब nitrogen के पास काफी negative charge आ गया है. And then you will add here Rx. Rx can be any alkyl halide. Okay. Rx can be any alkyl halide. Now this nitrogen is what? Having negative charge. This R is going to have what? Delta positive charge because it is attached with electronegative element. That is halogen atom. So this will attack like this. So this is again what? This is a SN reaction, nucleophilic substitution reaction. That is important. And after that, you will get nitrogen that is bonded to R. This phthalamides, other groups are still the same. Now, what is this? This is an alkyne. Phthalimide, because it is having an alkyl group attached with the nitrogen atom here, an alkyl phthalimide. Now, just in the presence of NaOH, in the presence of NaOH, it gives you double bond O, double bond O, O negative, Na positive, plus you get the R from alkyl halide and NH2. Okay, so this R is coming from what? R is coming from the alkyl halide. Please remember, if you want to have ethane amine, then you will use ethyl chloride or ethyl bromide or ethyl iodide. Okay, whatever alkyl group you want to have on the amine group, NH2 group, you are going to get it from the alkyl halide. Okay, please write here. This is phthalimide. Used for preparation of 1 degree amine. Next point, phthalimide on treatment with. Phthalimide on treatment with KOH forms potassium salt of phthalimide. Potassium salt of phthalimide. Which on treatment with alkyl halide forms N-alkyl phthalimide. Via, you will write via SN, nucleophilic substitution. Okay, via SN. And on further hydrolysis, it forms one degree amine. Now, why is SN very important? SN is important because SN reaction is not given by aryl. If, for example, अगर आपके पास आपको ये चाहिए NH2, then for this, the alkyl halide that you are going to use will be something like this. And this type of alkyl halide, they don't show SN. Why? Because this is partial double bond and it is difficult to break. We have seen that nucleophilic substitution reaction is not given by aryl halide. Okay, that is why it is important that this reaction happens via SN, and hence we cannot get 1 degree primary, 1 degree, that is primary aromatic amines. Please write a note here. These type of questions can be asked in Y. Okay, please write. Aromatic 1 degree amine cannot be prepared by this method as aryl halide don't show SN. Everyone done? Yes or no? Please tell me. Let me know if you're done.
Done, sir.
Right, next. Last method of preparation is Hoffman bromide degradation. This is also important. The sixth one. Hoffman bromide degradation. Here we take amide, RC double bond O, NH2. We react this with bromine in the presence of KOH. We can also use NaOH here, okay? We can also use NaOH. We are in the presence of KOH and we get RNH2. Okay, देखिए क्या हुआ है? This CO has vanished and it has formed K2CO3. Sodium hydroxide use करते तो NO2CO3. Thus you will get KBr. Thus you get H2O. But this RNH2 is important. That is 1 degree amine. Okay. So what is the important thing? Used to prepare primary amines. Next point. The reagent that we use here is Br2 plus KOH. The amine formed has 1 carbon less. Less than the amide. So if I use amide attached with benzene ring, C double bond O NH2, then in this case, Br2 plus KOH is going to give me aniline. Okay, so this is important. If you want to get a amine that is going to be 1 carbon less than the amide. Okay, it will be 1 carbon less than amide. These type of reactions are important in conversions. Please write this down. Then everyone, yes or no, please tell me. Okay. So for example, if you want to go from 1 to, these are 3 carbon atoms, NH2, 1 carbon, 2 carbon, 3 carbon atom, and you want to go to 1 and 2 carbon atoms and then NH2. Okay, 2 carbon atoms and NH2. So you are going to use Hofmann bromide degradation. So these type of reaction, we are having 1 carbon less. We are going to get 1 carbon less. So write this down. For example, if you want to go propanol, that means you have 3 carbon atoms and OH group to ethane amine. Okay, so see what you are going to do. So propanol to ethane amine. So 1 to 3 carbon atoms and OH group to 2 carbon atoms and NH2 group. So one thing is very important that you need to remove 1 carbon atom. ये 1 carbon atom removal वाला और amines को add करने वाला, you have only one reaction, that is Hofmann bromide degradation. So first of all, you need to convert this to carboxylic acid. To convert this to carboxylic acid, you will use KMnO4 oxidation. So you will get double bond O, OH, and then you will add ammonia, NH3. Okay, you will add ammonia first step, and in the second step, you are going to heat it up. In the second step, you are going to heat it up, and you will get what? First of all, you will get ammonium salt, and after that, you will get C double bond O, NH2. Okay, and after you get the amine, you are going to react this with Br2 plus KOH. Write this conversion. After conversion, you will write physical properties. Physical properties. In physical properties, we deal with boiling point and solubility. First of all, please write amines except 3-degree amines. Amines, but what? But except 3-degree amines can form hydrogen bond. Can form hydrogen bond. And hence they have higher boiling points than corresponding hydrocarbons and polar molecules. Now you will ask, sir, why does 3-degree amines do not have? Yes, Abdurrahman, you can use any oxidizing agent. You can use Na2Cr2O7, K2Cr2O7 also. Okay. Why 3-degree amines do not have hydrogen bond? Because in order to have hydrogen bond, for example, if you have R, nitrogen and 2 hydrogens. So these hydrogen will be delta positive, which can have some bond with hydrogen bond with the nitrogen atom. And this nitrogen atom is going to have hydrogen, and R. So this is 1-degree amine. So you should have nitrogen that is bonded to electronegative element nitrogen. Hydrogen bonded to electronegative element nitrogen. But in 3-degree amine, you have R that is bonded to 3 alkyl groups. This nitrogen is not bonded to hydrogen. That is why there is no hydrogen bond. Okay, so except 3-degree amines, all of the 2nd-degree amine and 1st-degree amine, they have hydrogen bond and they have higher boiling point than corresponding hydrocarbons and polar molecule. But please write a but. Boiling point of amines is lower than alcohol and carboxylic acid. Why? Alcohol and carboxylic acid, because the hydrogen bond of alcohol and carboxylic acid is stronger as it is formed by more electronegative. En is electronegative. En is electronegative oxygen atom. Okay, so if I talk about amines, then in this case, nitrogen with 2 hydrogens will have the highest, followed by nitrogen with 1 hydrogen, and the least will be nitrogen with 0 hydrogens. Now write one more point. Since 1 degree amine has 2 hydrogens per molecule, it can form more hydrogen bonds and therefore has higher boiling point than 2 degree amine. Let me know once you're done. I think you have written till here. Please write next regarding solubility. Amines are soluble in water as they can form hydrogen bond with water, but the solubility decreases as the number of carbon atoms increase in alkyl chain. And this point is consistent since we saw alcohols. Till then, as the number of carbon atom increases, the solubility is going to decrease. Right, next points. Amines are less soluble than alcohol. In water, and the hydrogen bond of alcohol and H2O is stronger. Now, right next. Chemical properties. Next, chemical properties. Okay, in chemical properties, first of all, we are going to deal with the basic character. Please write next first topic. Basic character. Okay, now in basic character, first of all, we'll see the reaction with HX, and then we will look at the basic strength, and then we will also compare different types of amines. Right, the first topic here in basic character. A is reaction with hydrogen halides. So if you react RNH2, any amine with HX, it is going to attack on the hydrogen atom, and it is going to form a salt, that is R bonded to N, and now 3 hydrogens with a positive charge and X negative. Okay, similarly, you can have. Okay, and these reactions are kind of reversible reactions. If you have NH2 plus HBr, let us suppose, NH3 positive and Br negative. Okay. Now, amines, they have basic nature. Why? Because they can abstract hydrogen. Why can they abstract hydrogen? Because they have lone pair electron. That means all the basic nature of amines is because of the electron density on nitrogen atom as the result of lone pair electron. Okay, so please write. Amines have lone pair electron on nitrogen atom, due to which they behave as Lewis acid. Sorry, they behave as Lewis base, not acid. Electron donating power, Lewis base. Now we know why they are acting as Lewis base. In the B part, we will look at the basic strength. How do we calculate the basic strength? We calculate the basic strength looking at the equilibrium when we have amines in water. So RNH2 plus H2O is going to give me RNH3 positive, and there will be OH negative in the water. There will be OH negative in the water. So the K equilibrium that we can have is the products upon the reactants. Here the product is R NH3 positive, the concentration of RNH3 positive, the concentration of OH negative, divided by the concentration of amine and the concentration of water. So as we know, water's concentration is going to be constant, and we can take it on the left hand side. So the equilibrium constant multiplied by the concentration of water is going to give you Kb in this case, because we are having base here. Now Kb for this case will be equal to R NH3 positive OH negative divided by RNH2 divided by RNH2. Okay. Now, as the dissociation increases, OH negative increases, then we can say that base is stronger, because if you have more OH negative, you'll have stronger base. You will have more OH negative, the Kb's value will be higher. So we can say that if Kb is high, then we have a strong base. Now, since Kb is a very huge number, we use pKb in order to measure. pKb is minus log of Kb. And if Kb is higher, the minus log of Kb will be lower, and that is why strong base have lower pKb values. Okay, please remember this. It has lower pKb values. If you have a strong base, then it is going to have a lower pKb value. As in the case of acids also. If you have a strong acid, the pKa value will be lower. It will be lower. Right. The next point, effect of subsequent. The C part. Effect of subsequent. Now, in effect of subsequent, we are going to also look at ammonia, 1 degree amine, 2 degree amine, 3 degree amine, because all of them, they have nitrogen atom. If you have 3 hydrogens, then what is going to be the case? Then you have nitrogen with 1 R group, any alkyl group, and then 2 hydrogens. Then you have R group, nitrogen with another R group and 1 hydrogen. This is 2 degree. And you can also have R, nitrogen, R, and 1 more alkyl group. Okay. So these are this is ammonia, this is 1 degree amine, this is 2 degree amine, and this is 3 degree amine. All of them are base because they have a lone pair electron. So as the electron density, see, there are 2 things that we are going to look here. Although the criteria for basicity, the basic nature, it is derived by some other factors also, such as solvation effect and other things. But we'll look majorly at 2 different effects. One is electronic effect and the other is steric effect. Okay, so what is electronic effect? Electronic effect just talks about where the electron is present. Now, if you are talking about a Lewis base, then the basic strength that we have, it is directly proportional to the electron density. If you have high electron density somewhere, then the basic character will be higher. Okay, then the basic character will be higher. So if I look at the electronics here, we are looking at the electronics. Now, in electronics, we know that the alkyl groups are electron donating groups. Alkyl group kaise hote hain? These are electron donating group. These are plus I groups. Right? So they will give electron here. In 2 degree, they will give electron from 2 sides. And in the 3 degree, they will increase the electron density at nitrogen atom from 3 sides. So can you tell me which is having the highest electron density here, guys? Ammonia, 1 degree, 2 degree, or 3 degree? Which is having the highest electron density here?
3 degree.
3 degree is having highest electron density, and that is why the basic character of 3 degree will be highest. So 3 degree, after that 2 degree, after that 1 degree, and after that NH3. Okay. Now this is still only one of the cases according to electronics. But if I just expand this thing, okay, na? And let us take the case of not R, which is very ambiguous, very vague. Let us take CH3. Okay. Now, in order to give the electron to hydrogen atom, they have to move. The nitrogen atom has to move, right? And it has to give the electrons to hydrogen. अब ये बात बताइए. Now we are talking about the steric effect. Okay, what is the sterics of basic character here? Now, according to this, tell me which is going to be easiest to move in all of these four. If you compare these four, which can move most easily? Ammonia 1 degree, 2 degree, or 3 degree? बताइए. Which can move easily and it can give electrons to the H plus ion. कहाँ पे सबसे आसानी से इलेक्ट्रॉन को दिया जा सकता है? If I talk about the space and if I talk about the bulky group that are present here, which is easiest to move? Which will be easiest to move? Ammonia 1 degree, 2 degree, or 3 degree? Look at the size and tell me. Which can easily move?
Ammonia.
Ammonia can easily move, right? The ammonia, अब इसके according, if I talk about steric effect, then NH3 should be, now this is basic character है ना, this is basicity की बात कर रहे हैं यहाँ पे हम लोग. Okay, so if I talk about the movement, then NH3 should be giving the electrons most easily, and then 1 degree, and then 2 degree, and then 3 degree, right? This is also for basicity. So there are two effects that we considered, electronics and sterics. Electronics mean we are getting 3 degree, 2 degree, 1 degree. In steric effect, if I take into consideration the steric effect for basicity, we are getting that ammonia should be the most basic. Now, both of these are conflicting. Yes or no? Please tell me, guys. Conflicting results, right? These are conflicting results, hai na? Yes or no? Please tell me.
Yes, sir.
So when you have conflicting result, then you go to the experimental result directly. Okay, so you cannot predict only by looking at the structure. You have to look at the data. You have to look at the values. So please write the point. Since the basicity is determined by multiple factors, with conflicting results, we will conclude with experimental results. Now, in experimental results, you have to remember two. If you have ethyl substituent and when you have methyl substituent. So when you have methyl substituent, in methyl substituent, the 2 degree is going to be the most basic, followed by 1 degree, and then followed by 3 degree, and after that you will have ammonia, NH3. Okay, that means you have CH3 whole twice NH. That is going to be the most basic, followed by CH3, NH2, followed by CH3 whole thrice nitrogen, which is followed by NH3. Okay, and then you have the methyl substituent, ethyl substituent, methyl to होगा, ethyl substituent. That means the nitrogen atom will have 2 carbon atoms. ठीक है, 2 carbon in the sense एक chain में 2 carbon. Ethyl group C2H5, CH2, CH3, C2H5. In this case, 2 degree still is the most basic, followed by 3 degree, and then followed by 1 degree, and then followed by ammonia. So here you will write C2H5 whole twice NH, followed by C2H5 whole thrice nitrogen, followed by C2H5 NH2, and then lastly we have the ammonia NH3. After this, you write aryl amines versus amines. Now we are going to compare aryl amines versus amines. Now, if I look at aryl amine, best example is aniline. You have NH2, lone pair electron, double bond, single bond, double bond. Now, this will be in resonance, and you will see that this electron is moving here like this, getting a double bond nitrogen atom, NH2 with a positive charge. And this is moving here, giving it a negative charge. Okay, and so on. Now, rest of all of the resonating structure that you are going to make, in that case, nitrogen is going to have a positive charge. यानी कि nitrogen की electron density उतनी है नहीं. Okay, but if you compare amines, you have R group that is attached with NH2, and this is going to give you electrons towards the nitrogen atom. है ना? So this is going to increase the electron density. You'll write here aryl amines are less basic than amines as the lone pair electron of nitrogen in aniline is in resonance with benzene ring. Making the lone pair less available. Right, next. But alkyl group is electron releasing group or donating group and increases the electron density on nitrogen in amines. ठीक है, right, next. Aryl amine versus ammonia. Now we know about aryl amine that it is not having a very available lone pair electron. We have seen that. Now let us also look at the product here. If I take aniline, in the presence of H plus, it will form anidinium ion. NH3 positive. Okay, NH3 positive. Now this aniline, it can have resonance like this. It can give the lone pair electron to this bond. It can go here, and if you make all the resonating structure, it will have 5 resonating structures. This has 5 resonating structures. Okay, you will say such same thing can happen here also. No? This lone pair can go here, and you will get this lone pair can go here, and you will get double bond hole like this. प्लीज लिखिएगा मत है ना. Some will make the resonating structure like this, NH3, and since it has got a electron here, you will get a positive charge here. But this is a wrong structure. Why it is a wrong structure? Because nitrogen is having 5 bonds. Nitrogen is a second period element. It can only have 4 bonds and 8 electrons in the octet. It cannot have more than 8 electrons. So this nitrogen can never have 5 bonds. Second period element में किसी के अभी 5 bond नहीं हो सकता. No one can have 5 bonds. So this is a wrong resonating structure. So this particular anilinium ion, it will have only 2 resonating structure, that is inside the benzene ring only. Okay, so benzene ring can have double bonds like this, and benzene ring can have double bond like this, and you will have the NH3 positive. ठीक है. Now this has how many resonating structure? 2 resonating structure. अब बताइए कौन ज्यादा स्टेबल है, रिएक्टेंट या प्रोडक्ट? Which is more stable, reactant or product, guys? Tell me. Look at the number of resonating structures and tell me which is more stable. 5 resonating structure is more stable या फिर 2? Tell me, guys, which is more stable, reactant or product? क्या ख्याल है? कोई ख्याल नहीं है? Think, guys. If you have more resonating structures, then you are going to have more stable, right? It will be more stable. So aniline is what more stable because it has 5 resonating structures than anilinium ion. And that is why aniline, it does not want to go into anilinium ion because it is less stable, right? The anilinium ion is what? It is less stable here because it is having only 2 resonating structures. And also this lone pair electron is not very much available for the donation on H plus ion. Okay, so please write. Next point. More resonating structure of aniline than anilinium ion and less availability of lone pair electron due to resonance makes aniline less basic. Right, next point. Electron releasing group such as OCH3 and CH3 increases basic strength. Electron donating group, electron withdrawing groups such as NO2, nitride, CHO, COOH, etc. decreases the basic strength. So majorly we can say that 2 degree is what? 2 degree is the most basic. Please write the basic order, general basic order. Two degree is most basic. After that, you can have 1 degree or 2 degree, 1 degree or 3 degree. तो उसमें हम aliphatic amine लिखते थे. Aliphatic amine वो depend करता है. अगर आपके पास मिथाइल है तो 1 degree is more basic. If you have ethyl, then it is going to be 3 degree, which is more basic. But always 2 degree सबसे ज़्यादा basic होगा. Then you will have the 1 degree या 3 degree. उसके बाद आएगा नंबर अमोनिया का. एंड अमोनिया से भी खराब कौन है? अराइल अमीन. Write a question. Compare basic strength of following. You have C6H5NH2. You have C2H5NH2. Then you have C2H5 fold twice. NH. And then you have NH3. So please write the question. I will give you like 2 minutes. Send the answer. Samira, correct. Yes, Samira, correct. Adriel, correct. See, guys, this is very easy. You just need to first of all come see what is this. C6H5 is what? It is aniline. So आपके पास क्या आ जाएगा? This is aryl. This is 1 degree. This is 2 degree. This is ammonia, right? This is ammonia. Now, obviously, which is going to be the most basic? 2 degree. 2 degree कौन सा है आपके पास? It is C. After that, aliphatic कौन बचा यहाँ पे? 1 degree. तो है D. And after that, you have ammonia, that is D. And then you have at the last arylamine, that is A. Please write this down. And then you will write the second reaction that it can show is alkylation. Please write alkylation. We have just seen the alkylation reaction. So what happens here? You have RNH2, 1 degree amine. You react this with some R dash halogen, that is alkyl halide. This nitrogen atom is going to attack on the R. This X is going to leave, and you are going to get this R group with nitrogen and the 2 hydrogens that were present already. Now, it will also get the R dash here. It will get the R dash and a positive charge. Okay, and a positive charge. Now, once you react this with base, you will get R, this nitrogen, this R dash as it is. The base is going to abstract the hydrogen. Hydrogen is going to give electron to nitrogen. And there will be only 1 hydrogen, and the lone pair electrons will be there as it is. Okay. Now, the same thing can happen once again. You can again react this with R dash X. And you will get tertiary. 1 more R dash. You're going to get tertiary amines. So please write 1 degree amines and 2 degree amines reacts with alkyl halide to form tertiary amine. Okay, so for example, if you have CH3NH2, and you react this with CH3 CH2Br, then you will get CH3 nitrogen with alkyl group and one hydrogen. Okay, then this is having lone pair electron. This was also having lone pair electron. Again, it will react with the same molecule, and you will get CH3 nitrogen atom, which has two ethyl groups attached to it. It has two ethyl groups attached to it. Okay. Now, important thing यहाँ पे जो आपको पढ़ना है, that is what is the name of this particular compound? What will be the name of this compound? Now, for those who have done naming with me, I use the SPUF method. We identify the functional group, unsaturation, parent, and then the substrate. Okay, so we'll go the same way here also. Okay. So see how to write the name. First of all, what is the functional group here? The functional group, since we are going to have nitrogen that is attached with carbon atoms, so it is going to be amine. So we have amine. Now, what is the unsaturation? Unsaturation, we don't have any double bond or triple bond. That is why it is going to be An. Now, what is the parent? Parent is important. What is the parent? Parent is something that is, we choose the parent and it should have the functional group. Now, if I look at the alkyl groups here, we have three alkyl groups, the methyl, and there are two ethyl groups. Okay. We can leave one ethyl group because both of the ethyl groups are same. Now, methyl and ethyl group both are connected to the nitrogen atom. So both of them can be the functional group. But what is the next rule? If everything is same, choose the one which is having the highest number of carbon atoms, and that is why we are going to choose the ethyl as the main chain. Now, since my ethyl is the main chain, I will add this to the main chain like this. Now, we have identified the parent as eth, only eth, not ethyl, like that, only eth. Now, whatever remains after the identification of puff, that is parent unsaturation functional group, is what it is a substituent. So we have CH3 as a substituent. Take this as some different color. We have CH3, and then we have a two carbon chain that is known as ethyl. So substituent is methyl, and then we have one more substituent which is ethyl. Now, but where are these methyl and ethyl? We have to number them. Obviously, these methyl and ethyl are not directly attached on the main chain. That is the two carbon atoms, eth, that is colored in magenta, purple, whatever you want to say, or violet. Now, ethyl and methyl, they are connected to nitrogen atom, and that is why we write N-methyl, N-ethyl. Okay. Now, here, if I want to write the name of this molecule, I will start with N-ethyl because according to alphabetical order, N-ethyl, N-methyl, ethane amine. Okay, there is a bit of less space here. Ethane amine. Okay. N-ethyl, N-methyl. Now, N is acting as a number. That is why N, after that, we have given dash. And N is separated by a dash because it is acting as a number. It is not actually a number, but it gives the position of the substituent group. That is why we treat it as a number. Please write this down. Similarly, what will be the name for this one? This will be named as N-methyl, N-methyl ethane amine. Okay, this one is named as N-methyl ethane amine. Because everything is same, we just don't have one ethyl group there. वहाँ पे substituent में N-ethyl नहीं होगा. That's it. Please write it down. I hope everyone has written this. Right, next, acylation. This is the third reaction. Yes, Josefa, okay, fine. Acylation. Now, acylation reaction is given by aromatic amines and aliphatic primary and secondary amines only, and they react with acid halide, anhydride, and esters, and they form amides. Okay, please write here acylation reaction. Okay, so in acylation, we will add a acyl group here. Just a second. Please write here. Let us take a primary amine NH2 plus C double bond O Cl. This nitrogen atom is going to attack onto this carbon atom because it is what delta positive, because it is attached with oxygen and chlorine. As soon as it attacks here, this will break and you will get Cl single bond oxygen, and it will be attached with nitrogen, and this nitrogen is attached with two carbon atoms, 1 and 2 carbon atoms. Okay, now this nitrogen atom also had two hydrogens, and that is why it will have a positive charge. Two hydrogens, which will give it a positive charge. Nitrogen has a positive charge, oxygen has a negative charge. Okay, now oxygen has a negative charge, it will slowly come down like this, and as soon as it will come here, what is going to happen? सबसे पहले तो आपके पास ये हाइड्रोजन आटम है ना, it breaks down because chlorine उसको लेके चला जाता, तो hydrogen gives the electron to nitrogen atom, and as soon as it gives the electron to nitrogen atom, what is going to happen? Oxygen gives the electron to carbon atom because chlorine is going to break the bond with carbon atom and go away with hydrogen. And what is going to happen? You will have 1, 2, third is nitrogen, fourth is carbon, fifth is carbon. Okay? So 1, 2 carbon atoms, third is nitrogen, fourth is again carbon, fifth is again carbon. Second is going to have a double bond O because oxygen's negative charge is coming down to get a bond here. Now, what is this? This is known as N-ethyl ethane amide. Okay, just remember nitrogen will have a hydrogen here because एक hydrogen बचा हुआ है इसके पास, and this is the subsequent, this is the main chain amide, and this is my substituent here. Okay, this is the substituent. Similar reaction is shown. Please write here aromatic and aliphatic primary and secondary amine reacts with acid chloride, ester, and anhydride to form amides. एक और रिएक्शन लिख लीजिए, यहाँ पे हमने सारे के सारे सी डबल बॉन्ड ओ देख लिया एक्सेप्ट फॉर दी कार्बोक्सिलिक एसिड ग्रुप. अगर यहाँ पे आपके पास सी डबल बॉन्ड ओ OH होगा and you have NH3, NH2 and R, this nitrogen atom will abstract the hydrogen and it will form a salt. You will get R, C double bond O, O negative, NH3 positive, and this nitrogen will have the R group. Okay, please write this down. Okay, if you have even acid chloride dekh liya humne, if you have even ester, or if you have anhydride, it is going to form amides. Anhydride one is important. You will look at the next class. Why is anhydride one is important? Right. The fourth reaction is important because it is a name reaction and it is also a test. Please write carbyl amine reaction. What is carbyl amine reaction? Please write. When you have a primary amine RNH2 and you treat this with CHCl3 chloroform in alkaline medium with some heat, you get isocyanide. Alkyne isocyanide is NC plus KCl, and you will get what? This is known as isocyanide, or it is also known as carbyl amine. Okay, and it has a very bad smell. It has a very foul smell. So if you have a primary amine, whether it is aromatic or it is aliphatic, both of them are going to give this carbyl amine test. Please write aliphatic and aromatic primary amine. Aliphatic and aromatic 1-degree amine reacts with chloroform and KOH at elevated temperature to form isocyanide. Right, next point. Isocyanide has a very foul smell. Has a very foul smell. Hence, this reaction is used for detection of 1-degree amine. Please write this down. Let me know once you're done. Uzaifa, you can take a screenshot. You have done carbyl amine reaction. All of you done writing? Yes or no? Please tell me.
Yes, sir, done.
Done. That's it for today. Okay, in the next, we are going to look at some other reactions of amines, and we will also look at the diazonium salts. Okay, diazonium salt is a small topic in the chapter of amines. We'll look at the diazonium salts on. Acha. How many of you can attend on Saturday? How many of you can attend a class on Saturday? No one else, only Samaira. Abdurrahman at real, what happened? Only morning around for you guys. Saturday will be fine, ना? Saturday क्या आपका वीकडे होता नहीं होता है? Uzaifa? Saturday is not a weekday for you. ओहो, कजिन्स को लेके बैठ के पढ़ाइए, अभी कजिन्स आ रहे हैं बच्चों के। हाँ, टाइम हम बता रहे हैं आपको। 10 How about 9:30 KSA? 9:30 KSA कैसा रहेगा? Fine with everyone? Huzaifa, you can take out some time, na?